Alright, let's take a look at some of these problems. The first one I'm going to look at is the integral x squared over x cubed plus 5 dx. Now, rational expression here in the integrand, what I'm going to do is let u equal x cubed plus 5, then du is equal to 3x squared dx. Well, I've got an x squared up here, and I've got an x squared there, but I want to do something with that 3, so I move it to the other side. 1/3 du equals x squared dx. So now this thing can be rewritten 1/3 integral 1 over u du, which is 1/3 natural log absolute value u plus c. And then we substitute back in what u equals. X cubed plus 5 plus c. And that's done. Alright. Now, the second one I want to take a look at is the integral for e to the negative 0.5 x dx. I would love if this was just e to a single variable. Oh, look at that. Sean Slocum got canned, just as I am speaking right now. Well, that's a happy day. But anyway, I would love for this to be just a variable. U equals negative 0.5x. So then du is negative 0.5 dx. But I don't have a 0.5 out there. I divide each side by 0.5, and this becomes negative 2 du equals dx. Alright, now this thing can be rewritten. I can take that 4 out in front of the integral sign because it's a constant, and I can put that negative 2 in front of the integral sign. Negative 2 times 4 is negative 8. Integral e to the u du. Well, that becomes negative 8 e to the u plus c, which is negative 8 e to the negative 0.5 x plus c. Did I let my integral go blind? Nope, I didn't. Negative 8 e to the negative 0.5 x plus c. Alright, let's take a look at another one. Integral secant squared x over 1 plus the tangent of x dx. Okay, again, this is just a little on the messy side, but a little substitution we can clean it up. 1 plus the tangent of x. Okay, how did I decide on that? Because the derivative of tangent is secant squared. And when I find du, that equals derivative of 1 is 0, derivative of tangent, secant squared x dx. So now, this can be rewritten as the integral 1 over u du, which is the natural log absolute value u plus c, which becomes the natural log 1 plus the tangent of x plus c. Alright, let's see. The next one we want to look at, integral 1 minus e to the 4x raised to the 20th power times e to the 4x dx. Okay. I would love for this stuff in parentheses to be just a single variable. So I let u equal 1 minus e to the 4x, and then du is negative 4 e to the 4x dx. Well, I got e to the 4x and dx right there. Move the negative 4 to the other side, and I got negative 1 over 4 du equals e to the 4x dx. So this can be rewritten. The negative 1/4 from the du comes out in front. Integral u to the 20th power du. Okay. When we do that, we get negative 1 over 4, 1 over 21, u to the 21st power plus c, which is negative 1 over 84, and I replace my u with 1 minus e to the 4x, which is what it was, 21st power plus c. Okay, great. Let's take a look at some derivatives now. And the first one is y equals 2x e to the negative 0.2 x. Well, to find y prime, we got to use product rule here. Derivative of 2x is 2. E to the negative 0.2x we're going to leave alone. Plus, we leave 2x alone this time. E to the negative 0.2x times the derivative of negative 0.2x, which is negative 0.2. And I'd be tempted to leave it just like that. Alright. The next one, f of x equals the natural log of 3x squared. Okay. So find the derivative, f prime of x. Derivative of natural log is 1 over the stuff inside the natural log, which is 3x squared, times the derivative of that stuff that was inside the log. The derivative of 3x squared is 6x. This one we could simplify right down to 2 over x if we wanted. Okay. You could leave it right here if you so desired, but that's pretty obvious. Simplification if you wish to do it. Alright. Let's take a look at another one. Y equals the log base 3 of the cosine of x. So, first thing I'm going to do with this is I'm going to write this as the natural log of the cosine of x over the natural log of 3. And then when I take the derivative, 1 over the natural log of 3 is just a constant, so it's going to stay there. The derivative of the natural log of the cosine of x is 1 over the cosine of x, and the derivative of the cosine of x is negative sine x. And again, you could leave it just like that if you really wanted. Or you could rewrite this thing as negative tangent of x over the natural log of 3. Alright. Let's take a look at another one. And what we have is y equals the natural log 6x minus 5 over 3x plus 1. And the first thing I'm going to do is I'm going to rewrite this as 2 logs. 6x minus 5, natural log 6x minus 5, and minus the natural log 3x plus 1. So then y prime, derivative natural log 6x minus 5 is 1 over 6x minus 5, the stuff inside the logarithm, times the derivative of the stuff inside the logarithm. Derivative of 6x minus 5 is times 6. Minus 1 over 3x plus 1 times 3. and that becomes 6 over 6x minus 5 minus 3 over 3x plus 1. Okay, good. Alright, let's take a look at one that I'm guessing is probably giving you guys fits. G of x equals 4 times 5 raised to the x plus 2 power. Now I know that you're all thinking, Mr. Hintz, what are we going to do with this? Well, I got a variable and an exponent and I don't like that, but I know how to get rid of exponents. I'm going to take the natural log of each side. So now I've got the natural log g of x equals the natural log of 4 plus, now, natural log of 5. The exponent comes out in front, so that becomes x plus 2 times the natural log of 5. I'm going to do one more simplification step. Natural log of 4. I'm going to do this distribution. Plus x times the natural log of 5 plus 2 times the natural log of 5. Now let's take the derivative. Natural log g of x, 1 over g of x times g prime of x. Natural log of 4, derivative of that is 0. Derivative of x times the natural log of 5 is natural log of 5. Derivative of 2 natural log of 5 is 0. So now if I multiply each side by g of x, I get g prime x equals natural log 5 times 4 times 5 raised to the x plus 2 power. Okay, and let's take a look at one last one here. F of x equals 10 plus 3x raised to the 8th power times 8x minus 9 to the 4th. I'm going to take the natural log of each side. We wouldn't necessarily have to with this, but we will just for fun. Natural log f of x equals the natural log of 10 plus 3x. Now instead of raising that to the 8th power, I'm going to bring it out in front. Plus the natural log, I can bring that exponent out in front, 8x minus 9. Now if I take the derivative of each side, I get 1 over f of x times f prime of x. That equals, well, I've got an 8, and that's going to be over derivative of natural log 10x plus 3x is 10 plus 3x times the derivative of 10 plus 3x, which is times 3, plus, well, I got a 4 here. Derivative of natural log 8x minus 9 is 8x minus 9 times the derivative of 8x minus 9, which is times 8. So now, if I do some simplification, multiply each side by f of x, I get f prime of x equals 24 over 10 plus 3x plus 32 over 8x minus 9 times 10 plus 3x to the 8th power times 8x minus 9 to the 4th power. And that concludes that, and I am just about out of time, so I'll let you all go. Thank you, and have a good weekend.